This is section 7.3 on the law of cosines. So far we've been able to use the law of sines to solve triangles. For these last two cases, we're going to need to know how to use the law of cosines to get it started, and then in the next steps then we can use the law of sines. Looking at the triangle side length restriction, if we have a triangle, the sum of the lengths of two sides of the triangles must be greater than the length of the remaining side. If we have this triangle, do you see how A plus B must be greater than C? To derive the law of cosines, we're going to take any oblique triangle ABC such that the vertex B is at the origin, and then the side BC is along the positive x-axis. And you could rearrange the triangle to come up with the other forms of the law of cosines, but we're going to just take it like this to derive it. Let x, y be the coordinates of vertex A. Now what we're going to do first is look at this triangle that's to the left of the oblique triangle. You see how this triangle here is a right triangle? I'm going to describe what sine of B is in terms of the sides of this triangle. Angle B is there. Sine of B, well, that's opposite over hypotenuse, so that's y over c. And then cosine of B is adjacent over hypotenuse, so that's x over c. If we solve the first equation for y, we'll have y is equal to c sine of B. Solving this next equation for x, we have x equal to c cosine of B. The coordinates of point A now become x, which is c cosine B, y, which is c sine B. And you can see that's what we have here. Point C in the figure has the coordinates A0, AC has length B, and the point A has the coordinates that we just found, c cosine B and c sine B. We can use the distance formula to write an equation. We're going to describe the distance of side B of the oblique triangle using this distance formula. So we have the square root, and then starting off with the difference in the x's, that would be c cosine of B minus A, square that, plus the difference in the y's, which is c sine B minus 0, and then squared. The next step is to square each side. If I square the right side, that just undoes the radical, so I'm just going to write the radicand, which is everything underneath the radical. I could drop that minus 0, and then we're going to multiply using, if we multiply that out, we'll have the first term squared minus 2 times the first times the last term plus the last term squared. I'll use that formula to simplify the first term squared. If you'd rather write it out twice in FOIL, that's fine too. If we square the first term, we're squaring each factor. Minus 2 times the first times the last, but I'm going to put the a in front to make it easier to read. And we have to be really careful because we have c and then cosine of B. The last term squared is a squared, and then square each factor, so we have c squared, and then sine is also squared. The next step, using the properties of real numbers, I'm going to get the c squared terms together and factor out the c squared. Bringing down the rest of the terms, the fundamental identity, well, that's the Pythagorean identity that we're using here. Cosine squared plus sine squared is 1. We have c squared times 1, which is just c squared. And if I rearrange the terms, I'll put the a squared term first, and then the c squared minus 2ac cosine of b. So this is one form of the law of cosines. If we rearrange the triangle, we can come up with the other two forms. We go to the next page. You see the three different forms of the law of cosines. In words, according to the law of cosines, the square of a side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the angle included between them. We are going to use the law of cosines to solve triangles that are in the SAS and SSS case.